In this lesson, we're looking at another way to solve systems of equations. Just to refresh your memory, so far when we're solving systems of equations, that means when we have two equations for two lines. So for example, y equals ax plus b for your first line, and your second line would be another y equals ax plus b, different a's and different b's. We're trying to find the point of intersection. So one line might be like this, and another line might be like this, and we're trying to find what is this point. The two methods we've seen so far are graphing, and we've seen the comparison method. Today we are learning about the substitution method. The steps for using the substitution method are outlined here. I'll quickly go over them, but then I'll illustrate them in the examples. So the first thing, when we are using substitution method, you're going to have two equations, and one of them will already be isolated for y, or it could be isolated for x. So you will have one equation that might be y equals ax plus b. Remember, the a and b, we'd have numbers in them, and you'd have your equation for x, which could be, for example, 3y minus 9, just for example. One of them will be isolated for x or for y. So step number 2, what we're going to do is we're going to substitute one of these expressions into the other. So for example, I'm going to take the x and I'm going to substitute it into wherever we see an x in this equation. It's very important that we use brackets. So we'd put this in brackets and replace the x with this bracket so that we can then use the proper BEDMAS rules. Once we've done that, we'll have an equation that we can solve for either x or for y. If we have a fraction, if we have fractions in our equation, remember, same steps as we've been doing before, create a common denominator for all parts of the equation so that we can then get rid of the denominator and continue to solve for x, or it could be for y, depends on what we're using. Once we've gotten rid of the denominator, we can solve for our variable x or y, depending which one we're solving for. And then the rest of the solution, the rest of the steps are the same as we've done before. Once you have your x or your y, you substitute it back into one of the original equations and you'll solve for the other variable, the x or the y, whichever one you haven't solved for yet. Let's try practicing those steps with a few examples. Let's try question A to start with. So we're asked to use the substitution method to solve for this system of equations. I'll start by examining the two equations that are provided. So this is the first line, y equals 2x minus 1, and then the next one, the other line is 3x plus 4y equals 18. Now I'm going to start with this one since the y is already isolated. This is what is going to be substituted into the other equation. So since it's y equals, this part of the equation is going to go in and replace the y here. So the first thing I'll do is I'll put a bracket around this part. Now whatever is in the bracket goes in and replaces y, since this here is already equal to y. So wherever there's a y, I replace it with that. Now I'll go ahead and write the new equation. So it's 3x plus 4, but instead of y, I put in that bracket, 2x minus 1 equals 18. Now I have an equation that only has x's in it, and I can use my algebra skills to solve for x. So the first thing will be to expand this bracket. I distribute the 4 to everything inside the bracket. So that makes 4 times 2x, that's 8x. 4 times negative 1, that's negative 4. And up here we still have our 3x equals 18. Now I'm going to collect like terms. 3x plus 8x, that gives me 11x minus 4 equals 18. I'm trying to solve for x here, so I'm going to try to get the x alone. I'm going to add 4 to both sides. So now we have 11x equals 18 plus 4 gives us 22. And the last step is to divide everything by 11. So my x is equal to 2. Now I'm not done. I've found the x, that's great, but now I need to find the y, because remember we're trying to find a point. A point has an x and a y. So to find the y, I do just like I was doing in the other methods we learned last time. I take the x and I put it in for either this x and solve for y, or this x and solve for y. It doesn't matter. Both come out to the same answer. You choose. I suggest you choose the simplest one, which would be this first one. So, and that's what I'm going to use in my example. So I'm going to write that first equation, y equals 2x minus 1, and I'm going to replace the x with the value that I just found. So y equals 2 times 2 minus 1. Solve for y. So y equals 4 minus 1, which equals 3. The last step then is to write what is the coordinate of the point of intersection that I just found. Well, the x is 2, so remember x's go first, then it's y, and my y is 3. So that is the point where these two lines are going to cross on the graph. Now I'd like you to try B, right here. I'd like you to try this example. Pause the video and try it, follow along on the steps that I gave you at the beginning and follow the steps that we did here. And I want you to try this one. Pause the video, give it a try, and then I'll show you the solution. Okay, so the solution to B, we're going to decide which equation needs to be substituted into the other. That's the first step. Well, since this one's already solved for y, this part here is what's going to be substituted in for y in the other equation. So now I have 3x plus 4, and instead of the y, I write minus 2x plus 1 equals negative 6. 3x, we'll expand this bracket. 4 times negative 2x is negative 8x. And 4 times 1 is plus 4 equals negative 6. Collect like terms. 3x minus 8x gives me negative 5x plus 4 equals negative 6. Trying to get the x alone, we're going to subtract 4 from both sides. So now I have minus 5x equals negative 10. And the last step, divide by negative 5. So I have x equals 2. Next step, what I found for x, I'm going to substitute it into here or into here. It doesn't matter. But the simpler one to use would be the second one, so that's the one I'm going to use. So the second equation was y equals negative 2x plus 1. I replace the x with 2. So now I have y equals negative 4 plus 1, which gives us y equals negative 3. So my point of intersection is 2, negative 3. Now we're going to take a look at example C. It's the same steps, but it might be a little bit more challenging because now we're going to have fractions that we're going to want to get rid of. So same thing as before, examine the two equations, decide which one's going to be substituted into the other. Well, since this one is already isolated for y, this is what's going to get substituted into this place. So this part here is going to get substituted into the y place. So we'll write our new equation, minus 2x plus negative 3 over 2x plus 9 over 2 equals 1. Well, since there's no number here in front of this bracket and it's not a negative, this is just really like having a plus 1 in front, we can distribute this plus 1 to everything in the bracket, but it's not going to change. We're multiplying each of these terms by 1, so they're going to stay the same. So we can just drop the bracket. Minus 2x minus 3 over 2x plus 9 over 2 equals 1. Now, we don't like having fractions when we're solving equations, so we're going to try to get rid of these fractions by finding a common denominator. So the ones that aren't fractions, we put over 1, and we need to decide what will be our common denominator. If I see I have 1s and 2s, so let's make my common denominator 2. So I'm going to multiply this by 2, but then whatever I do to the bottom, I have to do to the top. And same thing over here. This will be times 2, and this will be times 2. So now I'm going to have negative 4x over 2 minus 3 over 2x plus 9 over 2 equals 2 over 2. So since I have this common denominator, I can just take it off. Here's the equation I have left. 4x minus 3x plus 9 equals 2. Let's collect like terms and solve for x. Negative 4x minus 3x is negative 7x plus 9 equals 2. I'm going to subtract 9 from both sides. Let's continue over here. So that gives me negative 7x minus 7, equals minus 7. And then we divide by negative 7. So I get x equals 1. The last step is to solve for y. Now if we go back and look at our original equations, since this one here has fractions, I don't like the look of that. I'm going to use this first one. So I'm going to replace x with 1, and I'm going to solve for y. So it was negative 2x, but instead of x, I'm going to put in 1 plus y equals 1. So we need to solve for y. Negative 2 times 1 is negative 2 plus y equals 1. I'm going to add 2 to both sides to isolate my y. So I get y equals 3. Now the last step is to write our point. So our point x was 1 and our y is 3. Now I'd like you to take a look at this example here. I'd like you to copy this down into your notes, and I'd like you to try and solve them, just using the method that we've just been learning today. I'm going to check this in class to see if you've done the work.